All right, so in my attempts to be helpful and useful to my students, I'm going to go ahead and take a quiz and record like all the different particular problems that I'm given. So maybe you guys can learn from watching me. So here we go. It says let a of x equal this polynomial and let b of x equal this polynomial. Now, unfortunately for you guys, they gave me a very easy one. I wish it was harder, but it's not. Now, if you look at a of x, it says negative 18 x squared minus 6x plus 12. And it's being divided by the trinomial 3x cubed plus 9x minus 1. So we have some issues here. Yes, I know the issue is we're dealing with dividing polynomials, but the issue here is, look, that has a 2. That's raised to the power of 2. This is raised to the power of 3. So technically, this trinomial cannot go into this trinomial. So even if we were to set it up like we've set it up before, where we do long division, okay, so I'm going to go ahead and just do it, just so you guys, even if you got to this point, you're like, oh man, didn't even recognize it, okay? So here we go. We have negative 18 x squared minus 6x plus 12, and look what it's being divided by. The divisor is 3x cubed plus 9x minus 1. Well, literally, this can go into this 0 times. And 0 times all of this is 0. So when you take it away, this is your remainder. What? Are you kidding me? No, I'm not kidding you. This quotient, I'm just letting you guys know, that's the quotient. Literally, the quotient is 0. Okay, if that's the quotient, what's the remainder? The remainder is all of this. I'm not going to write it there, but I'm going to type it in there because I'm going to take this quiz. All right, here we go. So I'm going to put quotient is 0. There's the quotient. And the remainder is negative 18 x to the power of 2, or x squared, and minus 6x plus 12. Okay, so minus 6x plus 12. I'm just going to type minus 6x plus 12. And that's it. Okay, let's go on to the next question. Now this one's going to be an easier one. All right, we don't have to do long division on this particular one. All right, so you can see we have negative 12 x to the power of 5 minus 7x cubed minus 4x squared plus 6. So there we go. That's a of x, which is right here. That's a of x. Hopefully you can see that okay. All right. Then we have b of x, which is just an x. And so what we're doing here is we're doing a of x, and we are literally dividing it by b of x. Now this one you don't have to do long division on. You can just kind of put, okay, I'm going to divide you, and 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 we're going to divide you all by an x. All right? So think of it as x to the power of 1, okay? There you go. Now, the quotient rule states that if these are the same base, which they are, they're both base x, I can take these when I'm dividing, I can just subtract them. 5 minus 1 is 4. So negative 12x to the power of 5 divided by an x is negative 12x to the power of 4. All right, 3 minus 1 is 2, so this is going to be negative 7x squared. 2 minus 1 is 1, so this is negative 4x, but you don't have to put the power of 1, just leave it. And notice you can't divide that. All right, so actually our final answer, we could put plus 6 over x, but it's not asking for plus 6 over x. Here's what it's asking for. It's asking for what's called the quotient, which is q of x. So this part right here, this is the quotient. Okay? That's the quotient, which I'm going to put right in there. Now this is the remainder, but it's just asking for r of x, which is just the top number. So my remainder is just going to be a remainder of 6. If it said type in r of x over b of x, then I'd put 6 over x. But I'm just going to put just the 6 right in here. All right. So here we go. Let's go ahead and type it in. We got negative 12 x raised to the power of 4. And then what else did we have? We go back. We had minus 7x squared, x to the power of 2. And we had minus 4x. So I'll go ahead and put minus 4x. And that's it for that. Except now I guess I got to put a remainder of, whoa, I messed up there. I don't know what I did wrong there. My apologies. Whew, that was a close one. Let's put a 6. Before I do it, I could have typed in something wrong. So there we go. Negative 12x to the power of 4, minus 7x squared, minus 4x, and there's a 6. Okay, I feel better about that now. Feel better about that. Yay, we got it right. Oh, my goodness gracious. Pascal's triangle. I like it. Let's do it. Okay, this is Pascal's triangle. So it says use the binomial theorem, and we are going to expand this expression. All right, so if you don't know how to expand expressions, let's go ahead and do this one together and see if it works. All right, so go ahead and follow a pattern, if you would, with me. Okay, see, I'll scroll right there. Here we go. All right, so hopefully you guys see a pattern here. What we're going to do, I'm going to go, so we'll see what would be a good color. But I guess blue should work. So we have a 1 and a 1 and a 1, a 1, 2, 1. Now, here's what happens. You take 1 and 1, you add them together, you put 2. Put a 1, 1 plus 2 is 3. 2 plus 1 is 3. Put a 1. And then we're going to put a 1 here. 1 plus 3 is 4. 3 plus 3 is 6. 4 and 1. 1 plus 4 is 5. 10, because 6 plus 4 is 10. 4 plus 1 is 5. 1. And we're going to go 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And we put a 1. Now if we kept going down just a little bit further, we could keep going. Technically, we got 1 plus 6 is 7. We've got 21, 35, 21, 7, and a 1. So this is Pascal's triangle, and we're going to show you how to use it so that we can expand this binomial. Now, I want you guys to understand, this is called row 0, and row 1, and row 2. So this would be row 3. So I want you to think of this. This is like if you were raising something to the power of 0. This is if you're going to raise it to the power of 1. This is if you're going to raise it to the power of 2, to the power of 3, to the power of 4, to the power of 5, and to the power of 6. All right? So what I want you guys to understand is we are raising it to the power of 6. So we are going to be using this row right here. That's the row that we're going to be using. Okay? So right now, let's get your popcorn ready and get your pencils ready, and we're going to go ahead and get started. All right, so if you guys would, you're going to need to put this into your journal. I'm going to go ahead and go down a little bit here. Okay, you're going to need a little bit of room here. So what I want you to do is I want you to put the number 1, and I would like you to open up a couple of parentheses. We're going to put plus 6, and you're going to open up a couple of parentheses. You're going to definitely need some room on your paper. Plus 15. Then you're going to open up some parentheses. Then you're going to do 20. You're going to open up some parentheses. Now we get to go back down to 15, so put 15. We're going to open up the parentheses. All right, and we're going to go back to 6. Open up a couple of parentheses. And then finally finish off with 1, and we're going to open up a couple of parentheses. So if you're wondering where I got the numbers, I got 1, 6, 15, 20, 15, 6, 1. And I'm going to go back up here and take a look at it. It says m plus 1 over m to the power of 6. Here we go. So we have m plus 1 over m to the power of 6. All right, so when you guys are doing binomial expansion, here's kind of the pattern, all right? So let's go to start with just 2 letters, just basic letters, A and B, okay? If I have A plus B and I raise that to the power of 0, all right, like row 0, that's going to equal the number 1. But if I have A plus B to the power of 1, well, that's equal to just, see, we have 1 of each of them. That's just going to be A plus B. All right, so I'm going to go ahead and erase this real quick. All right, so let's see if you guys get this, if this makes sense. If I have A plus B squared, then that's going to be A squared plus 2AB plus B squared. Even though you can't see it, that's a 1, a 2, and a 1. If I have A plus B being squared. Now here's where it gets fun. If I have to say A plus B cubed, check it out. You're going to start out with A cubed plus, and then this is where it's going to get interesting. It's going to be 3A squared B plus 3AB squared plus B cubed. That's a B to the power of 3 right there. So this is where we start using what's called Pascal's triangle to help us with, okay, what numbers are going to go in this slot. So right now, we are all the way down to row 6. So that's why I start out with a 1, a 6, a 15, a 20, a 15, a 6, and a 1. Now, ours is a little bit different. It's not using A and B. It's using m and 1 over m to the power of 6. So here's what I'd like you guys to do. We're going to call this our A. We're going to call this our B. So what I'd like you to do is I want you to put your A here. We're going to put B here. So I'm just going to put it in the slot. Okay. So there's your M. There's your 1 over M. M, 1 over M. M, 1 over M. M, 1 over M. All right, now, here's the next thing we're going to do. All right, we're going to start out. Remember, we're raising to the power of 6. So here we're going to do to the power of 6, and this is going to be to the power of 0. Here, this is going to be the power of 5 and the power of 1. Here, it's going to be the power of 4, and this is going to be to the power of 2. Here, it's going to be to the power of 3 and to the power of 3. Here, 2, 4. Here, 1, 5. And last but not least, here, 0 and to the power of 6. So I want you to notice a little pattern here. All right, check it out. This goes from what? 6 to 5 to 4 to 3 to 2 to 1 to 0. But on this side, it goes from 0 to 1 to 2 to 3 to 4 to 5 to 6. And what are their sums always equal to? Their sums are always equal to 6. Why 6? Because we were raising everything to what? To the power of 6. So now all we're going to do is we're just going to work our way down here. Okay? We're just going to work each one of these. All right? So check this out. If I have 1 times m to the power of 6, and we got times 1 over m, let's evaluate it. We have what? M to the power of 6 being multiplied by 1 over m, which basically means I'm dividing it by an m. Now, maybe for some of you, maybe I'll need to do it. Not the shortcut, but maybe I need to do it. So we have 1 times m to the power of 6 m to the power of 6 times 1 over m to the power of 0. Now, anything to the power of 0 is just the number 1. So if I go over here and I say 1 to the power of, oh, I guess you can't see that. 1 to the power of 0 is 1. If I say 1 divided by 5, and I raise that, oh, I got to do the whole thing. Do alpha y equals enter. So 1 over 5, and I raise that whole thing to the power of 0, still equal to 1. All right? So right here, that's just going to equal a 1, and I'm left with m to the power of 6. So that's my first term, m to the power of 6. Now over here, I'm going to do the next one. All right, so we have a 6. We have 6 times m to the power of 5 times 1 over m. Now 1 over m is like basically do m to the power of 5 over m. And so you'll notice you can subtract it. So that's going to become 6m to the power of 4. And that's going to be my final answer for this one. So here we go. First one's m to the power of 6. Second one is 6m to the power of 4. We're just going to work our way down. Just do it step by step. All right? So here we have 15. We have m to the power of 4. And this is 1 over m being squared. So that's like saying 1 over m squared. So that becomes 15 m to the power of 4 over m squared. And 4 minus 2 is 2. So this becomes 15m squared. And you're done. Let's work on to the next one. We've got 20 times m cubed, because m to the power of 3 is m cubed. And we have 1 over m cubed. So what happens there? Well, that becomes m cubed over m cubed. Those cancel to a 1, so you're just left with 20. And you're done. All right? All right, here we go. Let's check it out. Let's keep going. Plus, what do we got? So basically, each one of these, all I'm doing is I'm going to be putting a plus in between them, okay? Because everything's positive. So here we have 15 times m squared, because m squared is m squared. And 1 over m to the power of 4 is 1 over m to the power of 4. So all I'm doing is simplifying. So I got m squared over m to the power of 4. Now 2 minus 4 is a negative 2, but we're actually going to leave it like this. Watch, we're going to leave it as 15 over m squared. That's what I'm going to write into the Khan Academy. So understand, if I did m to the power of 2 minus 4, and I got m to the power of negative 2, that's the same as saying 1 over m squared. So I'm just going to leave it as a positive exponent. I'm not going to type it in as a negative exponent. Okay? Almost done. All right, so we got 6. M to the power of 1 is just m. And 1 over m to the power of 5 is 1 over m to the power of 5. So what do I have here? I got m 6 times m over m to the power of 5. Now that's m to the power of 1. 1 minus 5 is negative 4, but we're just going to leave it as 6 over m to the power of 4, because one of these cancels out one of these, and you got 4 left. All right. We are like literally almost done. All right. Now, we have a 1. We got m to the power of 0. Remember, any number to the power of 0 is 1. So basically, our final thing that we're going to do, our final one is just 1 over m to the power of 6. And that's what I'm going to type in to the Khan Academy, just step by step. Whoa, whoa, whoa. How about this? How about I write the whole answer out so you can see it before I type it in. Here we go. Final answer. M to the power of 6 plus 6m to the power of 4 plus 15m squared plus 20 plus 15 over m squared plus 6 over m to the power of 4 plus 1 over m to the power of 6. And that's our final answer. So I'm going to carefully type that in as nice and neat as I possibly can. Whew, here we go. M to the power of 6 plus 6m to the power of 4 plus 15m squared plus 20, because on that one all the m's canceled out, plus, and then we had 15, we had a fraction though, we had 15 over m to the power of 2, or m squared, or no wait, it was m to the power of 4, let me look, m squared. Then we had plus, we had another fraction, 6 over m to the power of 4. Alright, and 1 over, finally, plus 1, let's do it, make another fraction. 1 over m to the power of 6. Wow, let's just, before I hit check, let's make sure I typed everything correctly. M to the power of 6 plus 6m to the power of 4, yes. 15m squared, yes. 20, yes. 15 over m squared, yes. 6 over m to the power of 4, yes. 1 over, okay. So finally, thank goodness we got all that right. Now you can hit C step-by-step solution if you miss it, okay? All right. So basically, you can see how they did the rows just like we did the rows. Okay. Now in the calculator, you can kind of find those rows if you wanted to. I'm going to go ahead and clear this all. If you go to your probability, if you hit Math, go over to Probability, and you go to NCR, which is your combinations, you press Enter. You can say 6, choose 0, and that gives you your first. If you scroll back up there, you say 6, choose 1. See how it goes 1, 6. And then watch what happens here. You do this. 6, choose 2. And you'll see it pops out of 15. So you see the pattern, what I'm doing there, hopefully. So if you ever are dealing with, like, you want to find it quickly without having to, like, use Pascal's triangle, you can use this method to find your coefficients that you need. Okay, so hopefully you kind of see the pattern, right? 1, 6, 15, 20, 15, just like we found here. 1, 6, 15, 20, 15. All right, so there we go. On to the next question. All right, so we got one more. We got one more Pascal's triangle. This one, you know what? It's not going to be that hard because look, it's also raised to the power of 6. So this will be a good question. We'll just do this one a lot faster. So you guys already know that our pattern on this one. Okay. So I'm going to go and take a screenshot real quick. I'm not going to redo Pascal's triangle. We already know we're going to do 1, parentheses, parentheses, plus 6, parentheses, parentheses, plus 15, plus 20, plus 15, plus 6, plus 1. All right, now all we got to do is just take a look at our two variables, z and a minus k. And that's going to be important that we have to use z and a minus k. I wish they would use different letters than z and minus k, but that's what we're going to do. You ready? So you're going to literally put a z in the first slot. And we're going to use a k in the next slot. But we're not just going to use a k, we're actually going to use a negative k. So that's one thing you're going to have to pay very close attention to when you're doing this. Okay, so this has got to be a negative. That's got to be a negative, and a negative, and a negative, and a negative, and a negative. Okay, so understand this, whatever that number is, goes here all the way across. All right? And whatever this value is, whatever that term is, You have to use that term. So we had to use a negative k every single time. Hopefully you can see that this is, I'm trying to make it a negative. I'll do a better job there. There's a negative, there's a negative, there's a negative. Now, this is easy. 6, 5, 4, 3, 2, 1, 0. And we go the other way. 0, 1, 2, 3, 4, 5, and 6. All right? So this is going to be very, very easy. We know z to the power of 6 is just z to the power of 6. Okay? Then we could plus, oh, wait a second. Actually, I'm not going to do plus here. We have a negative k. All right? So if that's a negative k, it's going to end up being a minus 6 z to the power of 5 k. Now, a negative times a negative is a positive, so that's going to end up becoming plus 15 z to the power of 4 k squared. Here's an odd number of negatives, so it's going to end up being a minus 20 z cubed k cubed. Here's an even amount of negatives, so those are going to cancel out, so I'm going to be left with plus 15 z squared k to the power of 4. That's an odd number of negatives, so it's going to stay minus 6 z k to the power of 5. And once again, we have an even number of negatives, so it's just going to end up becoming plus k to the power of 6. And that's going to be my final answer. And that's what I'm going to type. That's what I'm going to type in carefully. All right, so here we go. So we have z power of 6. I wish they didn't do all the way to the power of 6. It takes forever. All right, minus 6z k to the power of 5 plus 15 z squared k to the power of 4 minus 20 z, oops, not the x, z cubed k cubed. All right, I think we're doing so far so good. Plus, see, it kind of goes back and forth. It goes plus then minus and plus then minus. Okay, plus 15 z. Yeah. What the heck did I do wrong here? Hold on. I messed up here. It's supposed to be z to the power. I'm supposed to. My apologies. That's supposed to be to the 5. Dadgummit. It's okay. Hopefully I won't mess up there. So that's supposed to be, my apologies, that's supposed to be a 4. That's supposed to be a 2. There we go. Now we're back in order. All right. Good. You saw me mess up. So you need to check. That goes from 6 to 5 to 4 to 3. Now we're to the 2. My apologies. Wish I could go back in time and change that. But, okay. Minus 6 z k to the power of 5, and then put plus k to the power of 6. So I'm going to take a quick look at this, make sure I have everything typed in. Hopefully it didn't mess me up when I had to go correct it. So z to the power of 6. Let me look at it real quick. Minus 6z to the power of 5. Plus 15z to the power of 4 k squared minus 20 z cubed k cubed plus 15 z squared k to the power of 4 minus 6z k to the power of 5 plus k to the power of 6. All right, I think I got everything typed in. We'll see what happens. Yes, got it right. All right, so here we go. We have the one final last problem, and then this video is done. All right, so here we go. We're going to take negative x to the power of 4, okay? So we're going to take negative x to the power of 4, and we are going to divide it. We're dividing it by x squared plus 1. All right, so we're just going to take this and divide it by this. So first thing I'm going to do is I'm going to put a negative x squared up here, because x squared times a negative x squared is negative x to the power of 4. All right, and a negative x squared times a 1 is a negative x squared. I'm going to put parentheses around it, and I'm going to subtract it. So these cancel out. A negative times a negative is a positive, so I'm left with a positive x squared. And I know x squared goes into x squared a total of 1 time. So 1 times x squared is x squared, and 1 times 1 is 1. But this is where students will forget. They'll forget to put a parentheses and subtract it. Now these zero out, but negative times a 1 is a negative 1. So that's my remainder. My remainder is a negative 1, and this is my quotient. So my quotient is this. Okay? And my remainder is this. All right, so let's see if I get the final one correct. All right, here we go. So we got negative x to the power of 2, and I put plus 1. That's my quotient, and I believe my remainder was negative 1. If I get it right, I get it right. If I got it wrong, I'm probably tired from doing all that binomial expansion, but we'll see what happens. I got it right. So the step-by-step solution, and you can see that they did the exact same way. So if you guys get it wrong, it'll kind of, at least you get to kind of see them do the process. All right. Hope this video was helpful and you got a little introduction to binomial expansion, and you have a good day. All right. That's all she wrote.